Hello everybody. Once again I am here with you for the another session of the simplification of Boolean expressions. In previous session we have seen little bit four expressions or the equations that we have simplified using the Boolean laws, Boolean algebra laws or rules you can say. Here is one another example: AB and C or D complement and AB whole complement. It is just like this. So it is very easy to simplify this, and in both way you can simplify either using the De Morgan's law. We have to solve this complement of sum is equal to product of their complement, and complement of product is equal to sum of their complement is to be there. Two laws are to be very much important. That's why the maximum importance is there for the De Morgan's theorem, which gives us conversion from the AND operation to OR, and OR to AND in complement cases are to be there. So here one logic is to be expressed for simplification of this equation. And if you look at first case where the AB and C or D complement and AB whole complement is to be there. So this is what the product complement of the product is to be there. And here is to be as an one AB, another term is to be there, but this is in a whole bracket. That means this is one complete term and this is another term. So these two terms, and what is going there, and operation is there in between these two terms are to be there, and it is complete complement is to be there. So what is that law? That it is another law, second law of the De Morgan's, which stated that complement of product is equal to sum of their complement. Here it is the product is to be there, we can convert it into sum part is to be there, sum of their complement. So this will divide this complement part, and that's why this AB will be complement or with this term AB, and C or D complement whole complement is to be there. This complement is distributed somehow, some of their complements are to be there, because these are two terms where the product is to be there and that is complemented. Again we can simplify this term as AB and C or D complement. These are two terms in which this AB and C or D complement, these are the two terms, and what is going on, product is going on, and it is complete complement is to be there. And that's why we can use De Morgan's that same law. The complement of the uh, product is equal to sum of their complement. So here it will be AB complement or C or D complement whole complement is to be there. One complement is already there with the example, and another one is to be using the De Morgan's theorem. So complement of the complement, that is complements rule, original will be there. That's why C or D is to be remaining. And this is what the plus or AB complement. Now again if you look at this term, this AB or this AB complement is to be there. So either we can take when we will take it separately, because here now addition is to be there. That's why AB complement or AB complement is always to be, we will simply write once as an AB complement. And this is again the De Morgan's theorem we can apply here, because A and B are the two terms and the complement and operation is going there. And here product is to be there, complement of product is equal to sum of their complement, and that's why A complement or B complement will be there as an. Again complement of complement, original C or D. Again here the same thing is to be there, A and B complement. That means the complement of product, we will write product of their complement, sum of their complement, A complement or B complement. A or A complement or A complement, A complement we can write. Again B complement or B complement, we can write B complement. Again or C or D is to be there, so as it is. So this is what the simplification, where it gives us output A complement or B complement or C or D is to be there for this expression. Let's move on towards the another one. And here is the same again, another example with the complement part. Here AB complement or A complement or AB whole complement is to be there. So this is one another example with the complement parts are to be there. So either you can apply it directly as an complement, or you can simplify using short complement. Here just if you will look at this AB, the logic here used only solved for this AB part is to be there, and AB is complemented, and there is a product in between A and B, and there is complement of that AB is to be there. So it is nothing but to be a complement of product is to be there. We can write sum of their complement. That means here written A complement or B complement. Whole complement we are not doing anything with this. Again, or A, that is to be there, or AB is to be as it is to be there. So with this simple part solution of this AB complement, we have A complement or B complement, or A complement as it is, or AB whole complement is to be there. So this is what we have right now. Then again, if you look at A complement or A complement, I can write one A complement is to be there. B complement or AB as it is to be there. But again we have the another law 14, that is B complement or B and A is to be there. So in general we have the law is to be as an A or A complement B is to be there. We can write is equal to there for A or B is to be there. That was the law. That means one variable plus variable's complement into another variable is always equal to first term variable or plus with the another variable. But here the first term is complemented already. That means for this case it is also to be, we can write B complement or B complement of the complement, double complement is to be there. A will be always written to be as an B complement or A is to be there. So for this law is going to be the similar. Only the first term, instead of taking normal, we will take it as a complement is to be there. So we can write in this fashion. So with that rule number 14 same is to be there, we can write B complement or A is to be there. Again A complement or A is to be there, and according to the OR law, wherever the A complement or A is to be there, that value comes to be 1, and 1 plus B complement, and whole complement is already there. 1 plus B complement whole complement is to be there. That will also gives us 1, but 1 complement is to be there, and that's what 1's complement is nothing but to be a 0 is to be there. So that's why the answer will be 0 in that case. If you look at here, this is what, because 1's complement is 0. So this is what the solution for this expression or the equation is to be there. Let's move on towards another one. Here is the one another simple one example. So here AB or AC complement or AB complement C and AB or C is to be there. Simply multiply this term AB complement C with the AB or C. जर समजा मी याच्यासोबत जेव्हा मल्टिप्लाय करेल तर काय होईल, सिम्पली आता ए बी और ए सी कॉम्प्लिमेंट ॲज इट इज, मग ए बी कॉम्प्लिमेंट सी अँड ए बी और ए बी कॉम्प्लिमेंट सी इज टू बी देअर. इथं सी दिसत नाहीये पण सी आहेत, हिअर इट इज टू बी सी. ए बी सी is to be again there. So this is what the case where we have the expression simplification like this. But if you notice here is B and B complement, and B and B complement is always to be as a 0. So everything will become to be 0 for this term. C and C is always 1C, and that's why AB complement C we can write. For this it is 0, and for this AB as it is we are writing, and AC complement as it is AC complement is to be there. So the term is remaining AB or AC complement or AB complement C is to be there. Again to be here AB, this is AC complement, that's why it is the complement of product is equal to sum of their complement. A complement or C complement we can write, or A B complement C as it is. This is AB and C complement, A complement, or A B complement C. Again we will use the same law what I expressed, 14 number law. Here is we will take the nearer this AB nearer to this A complement, and this C complement with this B complement C is to be there. And if we rearrange, reshuffle this case where A complement or AB or C complement or B complement C is to be there. So with this again we have law number 14, that is first variable plus complement of that variable. A's complement is A double complement, and complement of the complement, that is original, that is the value is to be there. So in this case A complement or B, I can write this expression is to be, and here is the same C complement or B complement C. For this case also I can write C complement or B complement is to be there. So again it is simply, if you look at this case, here is B complement or B, which will gives us the value 1 is to be there, and 1 plus C complement is always to be as an 1, or again 1 plus A complement is always to be as an 1 is to be there. So the final answer for this case is nothing but to be 1 only. So this is one another simplification for the expression. Now let's move on towards the another one, which is to be as an simply given here as expression or the equation number 8 for the simplification, that is y is equal to wx complement and w or y plus w and y and w complement or x complement is to be there. Simply multiply with this term in the whatever in the bracket. So w x complement into w, that is w x complement w plus w x complement y plus wy w complement plus wy x complement. So this is what the multiplication simply is to be there. W and w, that is A and A, that is always A, that means w and x complement will be remaining. W x complement y as it is. If you look at w and w complement, it will give us 0 because A and A complement is always 0, and w y x complement as it is. If you look at this case where the wx complement will be common in all these three terms, so wx complement in bracket 1 or y, or here is y or y is to be there. So y or y, that is y, or 1, that is 1, and that's why the answer is w x complement only. So this is what the another simplification for this equation. And again thank you for joining this session. There is always, I told you that logics you have to develop in a different way. You can think in a different way, or you can develop your logic only and only when you know the laws very well. And that's why keep reading the laws and solve the different expressions. Thank you for joining this session. Again, be at home and be safe. Thank you.